All right, and I think we are live. Hey everybody, my name is Attila Toth. I'm a developer advocate at Timescale, and in today's stream, I'm going to show you not one but actually two applications or examples how to use AWS Lambda with TimescaleDB with your TimescaleDB instance. If you're watching the recording on YouTube, check the description because there will be links to relevant tutorials and resources that you might want to check out. And one thing before we start, from now on, we will stream every week on Wednesdays, 4 p.m. Central European Time and 10 a.m. Eastern Time. We are going to focus on obviously TimescaleDB, but other relevant technologies as well, just like in today's stream. And we are going to do interesting projects, benchmarking, and everything that could be useful for developers who are into time series data or who want to learn about TimescaleDB. Alrighty.
I'm not sure it's using your mic in front of you. Sounds.
All right. Yeah, let me check my audio settings in OBS. It should be using my mic. Weird. Yeah, I know I had issues with the audio in one of the streams in the past, but it should be good. I don't know. But you can like still like, or isn't it because you are you listening to the Twitch stream or in the meeting? Because the meeting uses my webcam audio. All right.
Thank you. Go ahead and start again, and we'll cut this out at the
We
beginning.
will cut this out.
Rock
All
and
right.
roll.
All right, cool. That was a practice run. All right. Hey, everybody. My name is Attila Toth. I'm a developer advocate at Timescale. And in today's stream, we are going to see two examples how you can set up AWS Lambda with a TimescaleDB instance. Basically, we are going to build a very simple AWS Lambda serverless application and another one with Docker to see how you can interact with your data with your TimescaleDB instance inside AWS Lambda. If you're watching the recording, make sure to check the description of this video because I'm sure there will be links to relevant articles, tutorials, resources, and also timestamps of this video, so you can skip to the specific part that you are interested in and just watch that. One more thing, from now on, we will do regular weekly Twitch streams on the TimescaleDB Twitch channel. So if you're not following TimescaleDB on Twitch yet, make sure to do that, and you will be able to join, ask questions during the stream. We're gonna watch the live chat, the stream chat. Yeah, that's that should be enough for now. So let me start today's presentation. I'm gonna have a short presentation part at the beginning, and then I'm gonna jump to VS Code and also doing some things on AWS console to show you how to set things up and how to use things. Alrighty, so today's agenda, first I will talk briefly about AWS Lambda if you're not so familiar with it. Then I will mention a few use cases where using AWS Lambda with TimescaleDB can be useful. Then we are going to build today's first very simple and quick application, which will be an HTTP API for TimescaleDB. We're gonna build basically a simple API to fetch data from a TimescaleDB instance. Then we will build our second application, which will be a little bit more complex using Docker, and we are going to basically create an automatic data pipeline that will, and as an example, you can build any kinds of pipelines, but as an example, we're gonna fetch data from a third party, in our case finance API, and we're gonna load that data into a brand new Timescale DB instance, and we're gonna do that using Docker to overcome some AWS limitations regarding the deployment package size. And then we're gonna conclude this presentation at the end. All right, so briefly about AWS Lambda. So if you're not familiar with AWS Lambda, it's a serverless computing platform, and it makes it very easy to just upload your function and then call it or trigger it in different ways. You can use Java, Go, PowerShell, Node.js, C#, Python, and Ruby as your programming language of choice. One huge benefit with AWS Lambda is that you don't need to manage servers at all. You can just upload your function and it will work, and you can scale up. You can also add layers. For example, we will in this stream we will add PsychoPG2 as a layer, and layers are useful to basically share the same module across multiple functions. So for example, if you want to create like a data pipeline, you will need in AWS Lambda, you will need some kind of a database connector library, and you can create a layer with this database connector library. In our case, it's going to be PsychoPG2 because we're going to do things in Python. And then you can have multiple functions using that layer to basically connect with your database. Now, there are some limitations with AWS Lambda. For example, the maximum timeout can be 15 minutes. So AWS Lambda is not necessarily good for really long running processes. You might want to decide if you have a long-running process or function, you might want to decide to break it into multiple smaller processes, or you just don't want to use AWS Lambda for long processes. Another limitation is the deployment package size, which can be up to 250 megabytes unzipped. This is because when you upload your code to AWS Lambda, you need to zip it, and the zipped maximum size can be 50 megabytes. Now, one thing which might be a question here is that, or might be an issue, is that when you add layers to your Lambda functions, the layers size will be added to the deployment package size. So basically your function, what you're uploading, plus your layers, package size together needs to be less than 250 megabytes, which is a problem if you want to use bigger modules in your Lambda function, like pandas and psychopg2 and some other bigger libraries. The 250 megabytes won't be enough, probably, but we will see how to overcome this issue in the stream with Docker containers. And yes, with containers, the max size can be 10 gigabytes, so you have much more flexibility regarding what libraries and modules you use in your Lambda functions. And also in your function, you can utilize a temporary directory that Lambda provides. The size of the directory is 512 megabytes. All right. So AWS Lambda and TimescaleDB use cases. Just to mention a few, you could build an AWS Lambda function to fetch data, and then you can use AWS API gateway to basically create an API for your TimescaleDB instance. We will do this use case today. You can also create an AWS Lambda function to insert data into the database using triggers. You can set up a lot of different kinds of triggers. You can also set up a trigger which basically behaves like a cron job. So maybe it runs every day or every week at a specified time. You can perform ETL operations, obviously. Create data pipelines from external sources. We're gonna create an application for this use case as well today, and etc. Basically, in AWS Lambda, if you can have a database connector library, which you can, then you can do anything with the database. You can ingest data. You can do any kind of ETL, so you have a lot of flexibility what you can do. All right, so first we're going to create an HTTP API, and we're gonna quickly jump to the AWS console to do this. But just on a high level, what we're going to do is first we're going to add the psychopg2 as a Lambda layer, and we're gonna do this. We're gonna be using the precompiled version of the psychopg2 library because Lambda cannot compile because psychopg2 is a C library, so you need to compile it normally. But we can use the compiled version of psychopg2, which is available on GitHub. Then we are going to create the actual Lambda function, which is gonna be just a few lines of code to fetch data from a TimescaleDB table. Then we are going to create the API gateway to basically provide a JSON if you request this API, and then we're gonna test the API. All right. So now let me go to VS Code. Actually, let me go to the AWS console. All right, I should have the proper screen. All right, so as we saw here, the first thing to do is add psychopg2 as a Lambda layer because we want to use the database connector library inside our Lambda function. But for that, obviously, we need to create a new Lambda function. So let's just go here, create Lambda function. Oh, so I'm inside AWS console, right? Let's choose Lambda. At the moment, I don't have any Lambda functions. Create function. So here we have several options. We can use author from scratch, use a blueprint, container image, browse serverless app repository. We're gonna go with scratch, author from scratch. We're gonna give it a name. Let's call it simple simple timescale, for example. So that's gonna be the name of the function. For runtime, we can choose the most recent Python version in AWS Lambda, which is 3.8 Python. I also need to set the correct permission, or sorry, the correct role. So the Lambda function will have all the permissions it needs. For me, it's Lambda. And then basically that's it for now. I can create a function. And once it created the function, as I said, it's gonna be a real simple app. So we're just gonna create the code using the editor inside AWS. So basically, AWS gives us, or the Lambda function gives us a Lambda handler function, and it needs to return something. In our case, we want this function to return data from the database. So now let's go check our database to see what we are trying to achieve. So if you haven't seen the previous Twitch streams on the TimescaleDB channel, I've been working on a finance project, which basically collects stock data, historical intraday stock data. We can have a look at the table. And this data set contains candlestick data. So you have time, you have opening price, closing price, lowest price, highest price, trading volume, and the symbol. And I think this data set contains data from the last more than 6 months. So we're going to use so if you're interested in this project, I highly suggest checking out the recordings on YouTube. I think the title is building a finance app with TimescaleDB or something like that. There will be links in the description. So we have this database, and what we could do is basically create actually, do I have the actual task on the presentation slides? Yeah, I actually do. So yeah, so we're gonna do these steps to create the API. And basically at the end, we want to create an API and it's just an example, but we want to create an API to fetch the most recent Apple stock prices. And for this, we are going to use a continuous aggregate table that we have created previously. So if we go back to dbeaver and check the views, there is a view called 2-week Apple prices. And basically, this is a continuous aggregate which contains the I think it contains the daily no the biweekly Apple prices. Let me start again. So it contains the Apple prices in Apple stock prices in 2-week buckets, and it has average price, max price, and min price. And the bucket day indicates the first day of the period, so the first day of the 2-week period. So we're going to use this table just as an example or view, and we are going to create our API to basically return the data from this continuous aggregate. Now, how do we do that? So if we go back to our console, so we have the function. Now we just need to create the code that actually fetches the data, and also in order to use PsychoPG2 here. So if I want to do import, actually it's really small. Maybe it's better. Maybe it's better this way. All right. So if I want to do import PsychoPG2, so this is not gonna work because AWS Lambda doesn't have PsychoPG2 as a library. But what we can do is, as mentioned on the slide, we can add PsychoPG2 as a Lambda layer. And to add as a Lambda layer, we need to use the precompiled version of PsychoPG2, which we can get from GitHub. I have a link here. So on GitHub, there's a repository AWS Lambda PsychoPG2, and this basically contains different versions of PsychoPG2, compiled versions. So we need to grab this library and grab this repository and use the one for Python 3.8. So if I download this repository, I find my project folder, which is AWS Lambda. So I put it here. I quickly extract it. So basically what we need is just the PsychoPG2 and 3.8. So I delete the other things. And in order to upload it as a layer for AWS Lambda, we need to put it inside a Python folder. So we create a folder Python. Let's rename this to PsychoPG2. Put this inside the Python folder, and then I need to compress it. And let's call it PsychoPG2.zip. So we have the zip, and basically this will be our layer. So going back to our function, we can scroll down to get to layers, or we can also click here, layers. So right now we don't have any layers. And if you want to add the layer, just click add the layer. And basically here you can choose your layers. Now there are some AWS provided layers if you want to use them, or you can have custom layers. Now I have one here, PsychoPG2, which I think I used before for testing. But let's create a new one, actually, because I'm not sure what this includes. So I will actually just delete this. Okay. Oh, because I have multiple versions, right? Okay, so now we don't have any layers. So to upload the PsychoPG2 layer that we just downloaded from GitHub, let's go create layer. Let's call it PsychoPG2. And then Python 3.8. I cannot. Okay, let's just say Python. Let's just say Python. So upload zip file, upload. Oh, we can actually specify the compatible runtime. So Python 3.8. So I don't even need Python in the name, just PsychoPG2. And basically that's it. We create the layer. And so we're gonna have, so it says version 5 because I already uploaded PsychoPG2 layers in the past, or I suppose with the same name. So that's why it has version 5. So now we have this layer which can be used in each Lambda function in the future. So if we go back and find our simple timescale function, we go layers and say add layer. We say custom layers, and we can select PsychoPG2 version 5 because that's the only one. So we add it. So with this, we will be able to use PsychoPG2 in our function, which is currently not doing much. But basically, we can test it because it would fail at line 2, import PsychoPG2. So if it doesn't have access to PsychoPG2, it will fail. So let's just test. So we deploy and then go test. Yeah, so this doesn't throw any errors, which means that it can use PsychoPG2. And that's pretty much the only external resource that we need here. All right, so we added PsychoPG2 as a layer. Now let's work on the Lambda function. We need to fetch data from TimescaleDB, which is this continuous aggregate. So let's create the select statement. So we can do SQL select everything from and this continuous aggregate called, I just copy this, 2-week Apple prices. So this is going to be our SQL. Then we're gonna use the PsychoPG2 library to make this request. And also I'm gonna quickly look for the cursor class that I want to use. Yeah, so we can do cursor. First, we need to create an object, a connection object. So let's do that first. So we need to create this connection object, and we need to provide the database connection details, obviously. And to do that, there are multiple ways to do that. You could well, it's not a good practice, but you could just hard code the connection details right here. But for now, we are going to use environment variables, which you can set up in the configuration tab. So just quickly save it, and basically, so in the configuration tab in your Lambda function, you could do this in using the AWS CLI, the command line tool as well, or the command line interface. But you could also just use this UI, and I'm going to use the UI now. So let's go here, environment variables, and you could define the database connection details here. So if we go edit, and we add the environment variables. So now I will need to look for my details for the database. Okay, so let's use DB user or just the DB prefix as a key, because we will need multiple variables for this. So we have DB user, we have DB host, port, database name, and I think that's it. Oh, and pass. And I will need to remember to hide that, so it's not public. But I can show the user. I think that shouldn't be a problem. So the host is this, port is this, database name is this, and the password. So let me hide it. Okay. Let me just quickly paste the password. Okay, so I added the password. I hit save. Okay. OBS. Okay, something like this. So basically, I have these environment variables. In AWS Lambda, which basically just stores the connection details for PsychoPG2. So let's go back to code. So now that I have those environment variables, how to actually reach them. So what you can do in Python is use the OS module and just use os.environ and provide the key, which in our case will be for the database name, it will be DB name. Actually, I think it's not even a function. I think it's dictionary. So I think that's how you're supposed to get it. So yeah, so it behaves like a dictionary. You could also do, you could do like this, or you could also do .get, And this way, if there is no DB name defined, then your code will still work. It will be just a non-value. But now we don't need this. And it's actually DB name, uppercase. So that's going to be the DB name. Then we have DB user, which is DB user. Then we have DB host, which is DB host. We have DB port. DB port, and we have the password. Which is DB pass. All right, so these are coming from the from environment variables, which are defined under configuration. So I think that's all that we need, and then we can create the connection object. Let me see if I can quickly copy that part, but no. So let's see, user equals DB user. Then database equals name, I think, yes. We have host, DB host, password, and port. Okay, that should be it. So let's see if it throws any errors. So I deployed it. If I test it, no errors. So that should be good. Okay, so right now, yeah, so we are trying to use this SQL, or use this query to fetch data from the database. So what we could do is create a cursor. And what I was looking, or what I was looking for is the, so yeah, we're creating cursor this way. But I'm looking for the dict cursor because I will need a dictionary as a result, so I can pass it to, or I can basically return it as JSON. So yeah, so I'm looking for this cursor factory and dict cursor. And for this, I will also need to import the extras module. Okay, so we have the cursor. Let's execute the query. cursor.execute SQL. And then basically the result will be cursor.fetch all, I believe. Let's print it. Oops. So if I deploy it, and then go test. All right, so in the output, we can actually see the data. So we successfully connected to the database, and basically what we have as a result is a list of well, looks like lists, but I believe these are because we're using dict cursor, so these are yes, these are not dictionaries, they are dictionary like objects. So let me because we will need a dictionary to be able to return that here in the body part, or we could just try to JSON dump this result. Let's see what that will do. Even though I think it will throw some error, but let's try. If it's not gonna work, then I will just iterate over the elements and convert them to dictionaries. Yes, it doesn't work because datetime is not serializable. Yeah. Oh, because datetime is not serializable. Yeah. So let's add a default argument to the JSON function. So it will not try to, or it will basically convert the datetime object to a string. I think that's how it works under the hood, because currently it the datetime object is not serializable, but a string is. So let's try now. So if I go test. Okay, so it looks like it works. Actually, I didn't even need to like create dictionaries. So in the body, we have something that definitely looks like a JSON list. Well, not really. Yeah, so it's not proper JSON just now. So let me iterate over the result. And we are basically trying to create a list of dictionaries. So let's just go to list of dicts. And we're going to create a dictionary from the row. I think it should work. And then we are going to put it inside the JSON function. All right, so it worked. So basically, I know it's not formatted well, but we will create the API just in a moment. So basically, in the body we have the key, which is basically the name of the column in the database. So we have bucket day, symbol, average price, max price, min price, and then next to it we have the value. and it's basically JSON, and this is the value that is returned by our Lambda function. So it's pretty simple. The Lambda function works. We have so we set up the environment variables. I use the AWS console, but you could use the AWS command line tool to basically automate it. Then based on that with those values, I created the connection object. Then I wrote this very simple SQL statement, which basically queries data from a continuous aggregate, which includes biweekly average and max-min Apple prices from the past 6 months. We use the dict cursor, and then we basically just iterate over the results to make sure that we can serialize it later, because we want to return a JSON. All right, so we have this function ready. Quickly go back to the slides. So we created the function. So step 2 is done. We fetch data from TimescaleDB. Now let's create the API using API gateway. So let me go back to yeah. So let's go back to the function. We need to add a trigger for this, and there are a lot of ways you can set up triggers. But now we are looking for an API gateway. So let's do that. We want to create a new API. It's going to be an HTTP API. It can be open. And I think that's it. Yeah, we don't want to change these settings. So let's click add. So this created an API gateway, which is connected to our Lambda function. We don't have any we didn't change anything here, but let's go here and try to configure some of the parameters. So currently, I think if we open this URL, internet server error, right? So we need to do we need to deploy it? I think we need to deploy it. No. So let's try to add the root, because we don't have any currently, and because our Lambda function returns Apple prices. So let's just create a get root, and let's call it Apple. Right, so now we have this get root. This should be the URL. It's enabled. or oh, because it created simple timescale by default. So probably, yeah. So basically by default, the API gateway creates a root, which is the name of the function. And yeah, actually, let's use this one. I thought it wasn't. I thought you need to create a new root. So let's just delete this one. Okay, so we have this slash timescale, simple timescale, which returns our data, which is great. Now the problem is that it's not JSON. I mean, it's JSON, but without it's not specified in the header that it's a JSON. So what we could do is go back to our function and basically add the header. So as we have status code, we have body. Let's add header. And I might need to cheat here. What's the exact name of this header? I think it's application something. Content type. It's probably content type. Okay, so it's content type. But how do you define that inside an AWS Lambda function? Oops. Okay, so we have some PHP here. Okay, so let's do header and an no application. Content type. So content type, and content type should be application JSON. Let's try this. So we deployed, and yeah, so we deployed. So now we just need to refresh this. Okay. What if I test? Yeah, I don't think this is how you specify that. Let me just do another Google search. Turn application JSON. I think I did the same thing. So yeah, I pretty much did the same thing. Anyway, let's try it again. So deploy, Not this one. Oh, there you go. Then I did something else apparently. Anyway, so this is how you say that it's gonna be JSON, and the browser will see the header, so the Firefox knows that it's JSON, so it displays it nicely. Okay, so basically we have this content segregated in the database. Then we went here, we created this Lambda function using PsychoPG2. I did as a Lambda layer. We defined the environment variables, or we defined the connection details, environment variables. We make the request and we return the data as a JSON as a JSON value. We set up the API gateway, and basically there we go. We have the average symbol, bucket day symbol, average price, max price, min price as a JSON list. All right, so that was the first example. And now we are going to jump over to the next part, which is let me quickly go to the presentation mode. Okay, so next we are going to create an automatic data pipeline with Docker. And basically, the reason we are using Docker is that, as I said at the beginning of the presentation here, so there are limitations with AWS Lambda, and one of the limitations is that the max deployment package size can only be 250 megabytes, which is an issue if you are trying to use pandas and maybe PG copy, as we are going to, and some other bigger libraries. You will easily end up with a deployment package which is bigger than 250 megabytes. And the solution to that, one solution is to use Docker and create a Docker container and upload, or create a Docker image and upload that in as your Lambda function, because that Docker image can be up to 10 gigs. So you have much more flexibility regarding what modules you use. You can freely use pandas and other Python modules that you want to use. So we are going to do that, and we are going to also do it in a real world way. So we're going to create an actual project, which I think I have a slide later on, so I will just talk about that when I have that slide. All right, so we're trying to overcome the 250 megabyte limit with Docker. Yeah, I said this already. Deployment package can be 10 gigabyte. Now, one thing is that you cannot upload like any Docker image. You need to your Docker image needs to implement the Lambda runtime API. And basically, the easiest way to get started is to just use an AWS Lambda base image, which implements the Lambda runtime API. We are going to use a Lambda base image. And here's an example for a base image, which is Python 3.8, and you can use this line in your Docker file, which I will show you how to do. You can use this line in your Docker file to create your own Docker image. So basically the steps that we need to take is when we have the project, we need to add, when we have the project, which is basically the Lambda function that we want to use. When we have that, we need to add a requirements text file to the project. This is important because then we will create a Docker file which basically will install everything that is in that requirements file. And as I said, the Docker file will need to be a Lambda base image, or it needs to implement the Lambda runtime API, but the easiest way to do it is to use a base image. And then we are going to use the AWS command line tool to build. Well, we will use Docker to build the image and then use the AWS command line tool to upload the Docker image to AWS ECR, which is Elastic Container Registry. So that's what we're going to do. And yeah, so basically the end result that we want to achieve here is we want to create an automatic stock pipeline. So basically we're gonna use the project that we have worked on in the previous streams. I mentioned it already, but you can watch the recordings on YouTube. We basically built a Python script that extracts data from a third-party finance-free API, and then it loads data into a TimescaleDB table. So we are going to use that project. We're going to build on that project and basically implement it using AWS Lambda. Right. So let me go back to VS Code. Okay, so this is the project. If you're not familiar with this code at all, that's fine. You can watch the recordings. You can also check the tutorial version of this project, which is available in the documentation. There will be links in the description. And basically you can, if you want to, you can build this project yourself. And it fetches stock data using the AlphaVantage API. Anyway, so we're going to use this script. Basically, we are going to modify it so it's compatible, or it can be used as an AWS Lambda function. So that's one. And the other thing is we need to Dockerize it and then upload it to the container registry on AWS. All right, so if we go back to the slides, so we already have the project, so that's done. That's great. We need to add the requirements text file if we don't have one yet, which we already have. Now I will probably create a new requirements file because we don't need a lot of these for the Lambda function. So for the Lambda function, we will only need PsychoPG2. We will need pandas, obviously. NumPy will be installed as part of pandas, so we don't need to specify that. We need requests because in the script, as you can see, we are making requests to the API endpoint. And we also need pgcopy because in this project we use pgcopy to pgcopy and the copy manager object, which is part of pgcopy, to basically insert data into the stocks intraday table. So let's create a new requirements file. Let's just call it docker requirements .txt. So basically we will need pandas, we will need requests, psychopg2. Now here, because we are using AWS Lambda, psychopg, if we just use psychopg2 like this, we will also need to install GCC or some C compiler, because psychopg2 is written in C. Now we don't want to do that because it would just make things more complicated, but we can use psychopg2 binary, which is basically a binary version of psychopg2, so you don't need to compile it. So we will use this one instead, and pgcopy. So this will be a requirement file. We might need to specify the exact versions for these libraries, but maybe not. So let's just keep it like this. So we have the requirements file, and then now we can create the Docker file. So let's create a Docker file, and basically, as we saw on this slide, we can use this base image. Now, how do I know about this base image? So in the AWS documentation, let me just close these tabs real quick. So in the AWS documentation, they actually tell you about these base images. They have base images for Node.js, Python, Java, .NET Go, and Ruby. And basically, if you go here, Python, you see that there is one for Python 3.8, 7, 6, and 2.7. And you can check the Docker file as well. You can check the Docker file as well. And also they have an example here, like they have an actual Docker file example, like how to use this base image. So we are going to do something very similar. As you can see here, we're going to use a requirements text file to basically pip install everything that we need as a dependency. And then we are going to specify our Lambda function as well. All right, so let's go back to VS Code. And let me just copy paste the Docker file that we'll need, and I will explain each line. Okay, so basically, as we saw in the documentation, we are using the base image provided by AWS. I create an app work directory. This is not necessary, but I create an app folder just to put everything in that folder. Then I copy these three files. So I copy first the insert stocksdata.py, which is the name of our ingestion script, which is actually extracting data from the API and then loading data into TimescaleDB. So we will need that. Then I will also have a symbols.csv file. Now this is needed because I have this CSV file here, which is actually doesn't need to be a CSV file because it's just a list of values. But anyway, so I have a list of symbols in this file, and basically the script uses this CSV file to make the requests to the finance API. So this is needed by the insert stocks data script. And then obviously the requirements file, which is in our case Docker rig text, which has where is it? Which has pandas, request, psychopg to binary, and pg copy in it. Right. And then we are pip installing everything from the requirements text file, and then specifying the Lambda function, which is, I think I need to rename this. So this is the main function of the script. And so to be compatible with AWS Lambda, I renamed this to handler, and also add event and context as parameters, because those are parameters, even though we are not using them. But if you want to use like the context or the event parameter that comes with the AWS Lambda function, you can do that as well. So this is our Docker file. And basically that's it. So if we go back to our slides, not here, here. So we created the Docker file, and then we need to build and upload the image. So to build and upload the image, we will need to so we can just build it with Docker, which is which is obviously a prerequisite for this project. So you need Docker to create Docker containers, obviously. So I will not show how to install Docker, but you will need Docker for this. Let me just open a new terminal here. So basically, we want to build this image, and let's call it stock or Apple. Let's just call it stocks image. And the Docker file is in this folder. So we're building this. And once it's done, we're going to need to log in to using the AWS command line tool. And we will need to then upload this Docker image. Okay, so there are some errors. I think it might be better to specify the version of these libraries, but let's see. Yeah, it's trying different versions. So let me just stop this and specify the library version so it doesn't look for the correct version. Okay, so this should make things quicker. So it struggles with PsychoPG2 for some reason. Oh yeah, because I actually forgot to add yeah. So this is interesting. So in the Docker file, I just installed the I just tried to install everything inside the, yeah, it doesn't even work. So I tried to install everything inside the requirements file, which is fine. But for PsychoPG2 binary, it looks like you still need to include a compiler or the Postgres Devel module. So if you do Postgres Devel, because Postgres Devel has, I believe, the library that it is trying to install and has issues with. And let's try GCC as well, even though I don't think you actually need it, but let's try this Docker file. Yeah, and I need to say or add this parameter so it doesn't stop if you need to like say yes to install stuff. Yum. Okay, so once it's done, it should work now. I think it just needed the Postgres Devel library, because Postgres Devel has I think the libq module, which is needed for PsychoPG2. Okay, so it will install a bunch of stuff, and then let's open the AWS CLI documentation, because that's the next step that we need. So in order to upload the image, we need to log in first with the AWS CLI or the ECR registry, and we can use the get login password comment for that, and some other parameters. But let's hope that our Docker file works, and we will have a proper Docker image. It's gonna be a really long stream, but we can add timestamps, so it shouldn't be an issue. So folks can like skip and find their parts, or find the parts that they are interested in. Okay, so it's still okay. So it still struggles with installing PsychoPG2, which is weird. Yeah, it tries to. It tries, yeah, because I haven't specified the exact version for the binary. Um, but it's looking for multiple versions of requests, even though I specified the exact version for requests. Did I make a typo or something? No. It tries to build it from the source, but why? So let's check psychopg to binary. So this is what I need. Um, what if I just install it after this? Okay, let's try to take a break until it installs things, and then I will come back when it's done and see if it works.
I'm sorry that you're running into issues. I'm sorry that you're running into issues. Yeah. Mm. Yeah, I feel like it's totally normal and like, I don't know, just shows the reality of development to have to, take a break and figure it out and then go back. Develop. So.
Okay, so we're back. So basically the issue was that, yes, you need the Postgres Devil library and also the GCC library, but the Postgres Devil library is spelled with like Postgres SQL, so not just Postgres, which I tried before. And apparently there's a library called Postgres, so that's why it didn't throw an error. But anyway, so it's Postgres SQL Devil, and that includes libq, which is needed for PsychoPG2. So now the image is successfully built and tagged, so that part is done. So now if we go back to the slides, so if we go back to here, requirements file, that part is done. Docker file is done. We also built the image, and now we just need to upload the image. So we're gonna use this example here using the AWS CLI, and we need the region, which in our case is US East, and also I will use the Docker command to log in. So let's go back to VS Code and try this. So we're logging into the AWS ECR registry. And one important thing which you need to do is you need obviously the your AWS credentials, which is the two, I think it's 2 access keys. So you need to either provide those access keys as part of the command as parameters, or I think it's a better way to use AWS configure, the AWS configure command, which will ask for the AWS access key, and then it will store the access key on your computer locally. And if you don't specify the access key, then it will just pick it up from your computer. So we are logged in, and we built the image. So basically we just need to upload the image to ECR using the create repository command, which I got from the documentation, which is this. So create repository, you need to define the repository name, and basically that's the only required parameter, which in our case is stocks image. So if we hit enter, it should upload the image to ECR. We have some response here in JSON, but if we go to the AWS console, so if we go, not this one, so if we go to the AWS console and check the registry, it should be there. Yeah, so we have the repository there, stocks image, created right now. So it's there, which is great. So now the only thing we left to do is to go back to our Lambda function and basically, well, create a new Lambda function actually, because we need a new function for this. But we create a new function, and here when we need to specify which, like how we want to create the function, we need to choose container image. Select a container image to deploy for your function. So the function name can be Docker timescale, for example. Or actually, let's go with Docker stocks, because it's to extract and update, or extract and insert stock data. So let's go with Docker stocks. The container image URI, we can browse this stocks image. It's not here. I think you need to add a version, so it actually shows when you create the Lambda function. So if we go back here, we open the image. No image tag. Oh, because I forgot to tag it. Right. Yeah, let's see how to do that. So AWS ECR Docker tag image. Or actually, I think, yeah, you can view the push commands right here. Yeah, sorry. So basically, you have all the commands here. If you go to the Amazon container or the ECR part of AWS console, view push commands, you basically just need to copy paste these. You need to copy paste the login command, which I already did, and then you need to tag it with the Docker tag command, which I forgot to do. So let's do that now. So this tagged the image, and we need to push as well. Yeah. Yeah, so previously with the ECR get login password, you just log in. Then with the create repository function, you don't actually like upload the image yet. You just create the repository in the registry, and then you need to tag the image, and then push it to the actual repository, and then you will be able to use it to create the Lambda function. And now it's loading it's uploading the Docker image. One thing that I found is that, so with the Docker image, as mentioned during the slides, you can go up to 10 gigs with the Docker image. And even though if you use the same libraries with a Docker image or without a Docker image, obviously with a Docker container, the package size will be bigger. Like for example, I think if you just have pandas, pgcopy, and maybe a few other libraries, that's gonna be around like, I don't know, 300 megabytes maybe without a container. With a container, it's gonna be around, I don't know, 600 or 700 megabytes, so it's gonna be much bigger. But with a Docker container, the maximum size can be much bigger, 10 gigs. So it's not a problem. So it's pushing things, and when it's done, and when I connect it to the Lambda function, we can basically set up a trigger to run run the function every day, every week, or whatever you want. Okay, so it's pushed finally. So if we go here, let's find our Lambda function. Oh, sorry, let's create a new Lambda function. So create a function. We use a container image. Function name docker stocks, for example. We find the image, and now it's there with the latest tag. So select that, and we select the role, create function. So this will create the function. We won't be able to preview the code because it's Docker image, and Lambda doesn't allow previewing if you use a Docker image. Okay, so we could test it, even though I just found one configuration error in the code because we forgot to add the API key. so it might not work. But let's add the other environment variables, just like with the other Lambda function. Okay, so we have DB user, DB pass, DB host, port, and one more, DB name. Okay. So if I save it, okay. All right, so we could test it to see if it works, but I think we need to provide the, yeah, so we actually, it will timeout error, I think, because the default timeout error is, or the timeout limit is 3 seconds. So we need to edit that. So go configuration. Actually, it might be here. Oh, there we go. General configuration, timeout. And the maximum is 50 minutes. So let's set it to 50 minutes. Also, I think I should give more memory just to be sure. Yeah, so I need to provide the API key as well, which I forgot to do. So we add one more environment variable, which will be API key, which is basically the Alpha Vantage Finance API that this script is using. So add that here. Let's build the image again. And we also add the API key as a configuration as an environment variable. Yeah, so we go here, API key, copy paste, save. That should do it. Okay, I don't have enough disk space on the root. Interesting. So let me let me find yeah, because I created so many Docker images, and I don't have that much space on the root folder or whatever. So what am I looking for? I'm looking for a way to delete Docker root folder or something like that. Remove unused Docker images. Okay, now we got 4.5 gigs back. So let's try to build it again. Actually, what I could do is set up quickly another table. Well, that's not necessary. We could just use the current one, because so this is inserting data into stocks intraday. That's the name of the table. And currently, if we find the most recent line or row in the table, order by time, So if you do this, we see that the most recent data points are from 6th of August. That's because I ran the script a few days ago, but we can easily test if the Lambda function works by running it again with Lambda and then check the most recent record in the database. So we built it. Now let's tag it with latest tag and push the container to the registry. And now it's gonna take again, like, I don't know, 5 minutes or so. All right, so the new Docker image is pushed. So now if we go back to the Lambda function, we go here, deploy new image. We need to select this image which was newly uploaded. This is with the latest image tag. The other one is the older Docker image. So we don't want to use that one. We want to use the latest one. So we select the image, we hit save. This will deploy the Docker image. As it says here, updating the function Docker stocks. So this is deploying the new the function with the new Docker image. And when it's done, we should test the function. Now I'm not exactly sure how long the function will run, but it shouldn't run that long because if we go back here, I only have 1 month of data to be fetched. So basically, it is fetching data from the last month. Also, I put in this slicing. I think that's what it's called. So basically, it just gets the it just updates the Apple prices, and it doesn't update all the symbols stock prices because that would be probably multiple minutes. But for Apple, it should only take I don't know, maybe 20 seconds or so. So we hit test. And if it works correctly, it should so it should run, and then it should say that returned nothing or null, because actually we don't return anything inside the handler function. But you know, you can return, you know, something like you know, successful data ingestion or something like that. But we can do it later. Okay, so execution result succeeded, null, as we see here in place of the return value, which is fine. Duration 21 minutes, or sorry, 21 seconds. All right, now the way to see if it actually worked is to go back to our database. So right now we still see the table, which is the result of the query I ran like, I don't know, 10 minutes ago, which says that the latest data points are from the 6th of August. Now, if I run this query again, we should see the most recent stock prices from the API, which should be stock prices from yesterday, which is the 10th of August. So if I run this again, we see that the times are updated. So the Lambda function actually works. And now we have the most recent, well, relative to the API, you know, because this is the most recent data points that API that we're using can deliver. But we see the most recent Apple stock prices from yesterday. And this is inserted using the Docker image that we just created and pushed to AWS. All right. So the last thing we need to do to make it really automatic, let's say we want to update, we want this database to be updated every day, every week, every other day, whatever you need, whatever you want to do. We can set up a trigger and then set up a trigger very similar to a cron job. So basically, if we go configuration, and then on the left side we say trigger, we click on triggers. There is no trigger yet currently set up for this Lambda function. So we say add trigger, And if you remember, in the previous application that we did, or in the previous Lambda function that we did, we used the API gateway because we wanted to set up an HTTP API request as a trigger. Now we could do that here as well, but we could also use something like Event Bridge, and with Event Bridge you can create a cron job like task. So if we go here, Event Bridge, we can create a new rule or an existing rule. We don't have existing rules yet, so let's create a new role. Let's call it daily Apple stocks, because basically the rule will make sure that our Apple stock updating script will run every day. So daily Apple stocks, the rule type. Now it could be an event pattern if we want to do event-based triggering, or we could schedule, and here we could do we can use a cron expression, or for example 1 day, as you can see here in these examples. So let's use cron, and for cron let's use a tool like this one to come up with the cron expression. So if you want to run this script every day, you want asterisk for in place of the day. You specify the hour and the minute. Maybe you want this to upload every 2 a.m. And every day. So if I'm correct, this cron expression will run the script, or if it was a cron job, then it would run the script every day at 2 p.m. So if we copy paste this expression here, you need to add cron and then parentheses, and this way Event Bridge knows that it's a cron expression. All right, and then we add this rule. It's not valid. Okay. Then let's not use cron, because they probably have like interesting, because it's a valid cron expression, but looks like AWS uses some kind of other format. So let's just use 1 day, which they have here as an example, and this should run every day, I believe. So if we add this, still not, oh, okay. So the event bridge trigger was successfully added. Schedule expression rate 1 day. So this should run every day. Now I'm still curious, if you want to use like a cron expression, then how do you do that? So let's see, AWS event bridge cron. So you need to say cron and then the field. Okay, so they have examples here. Oh, you need to use a question mark, not an asterisk. Okay, we can fix that. So let's try to edit this. rule. So if we say edit cron expression, then we can just yeah, so basically I need this so this is the correct format. Yes, this is the correct format. It actually shows you when it will run next, which is actually pretty useful. But it's interesting why they need question mark instead of asterisk. Yeah, it doesn't work only with question mark. Anyway, so if we want to run it 2 a.m. every day, this should do. You can also specify time zone. GMT is fine. All right. So let's say update, and it's updated. We have the target here, which is the Docker stocks Lambda function, and as we tested previously, and we checked the database, it works properly, so it should work the next time as well when it runs. All right, so that was the second application that we built. Now let's conclude this stream. So what we did basically, we have used Lambda to build a simple HTTP API to fetch data from TimescaleDB, and we use this API to fetch a continuous aggregate, which is a useful feature of TimescaleDB. And then just now we set up an automatic third-party data pipeline using Docker. When we basically used the project that we worked on in the previous streams, which is a finance project, and we used that project to basically Dockerize it and upload it into the AWS container registry, and then connected that to a Lambda function. And then finally, to top it off, we created an event bridge daily schedule. So the Lambda function runs every day, 2 a.m. And we use the cron expression to set that up inside event bridge. All right, so if you want to learn more, or if you want to try TimescaleDB, either locally on your computer, or you want to try the managed version or the managed service, you can go to timescale.com and just try it for free on timescale.com. You can also look at the other interesting TimescaleDB tutorials that we have in the Timescale documentation. Again, if you're watching the recording, there will be links for these in the description. We have tutorials for crypto use cases. We have tutorial for financial use case, stocks use cases. We have a tutorial for NFL fans. We have all kinds of interesting tutorials to help you get started with TimescaleDB. And then obviously, as I said previously, you can replay all the TimescaleDB Timescale live sessions, just like this one, on our YouTube channel. You can see all the recordings. Also, you can find some additional YouTube specific content on our YouTube channel. All right, so that was it for today. I hope it was useful. If you don't want to miss next future Twitch live streams, make sure to follow the TimescaleDB Twitch channel. Or we also do broadcast these live sessions on YouTube as well, so you can follow on YouTube as well. And thank you for watching. See you in the next